Okay, Year 12, here is 23C, which is about expectation in an experiment. So, what we expect to happen in theory is different to what actually happens in real life or in an experiment. So we usually say, like let's say there's n trials of an experiment, like that's the number of times you do it and you repeat it. And let's say the event we're looking for has a probability of p. The number of times we expect then the event to occur is quite straightforward. It's just n times p. Okay. The other language we use is we might say the expected outcome from one trial of an experiment in a particular scenario. But then when we're looking at repeating it, that's when we need to multiply. Now, if we're looking at, say, your random variable x, okay, but we want to know what that is, what the expected outcome for that is, okay, we can only find like an average of all of those outcomes added together. So you get a mean result. Mu is this Greek letter here. So usually this is the notation that we use. So we would say the expectation of the random variable x. So let's say x is, getting heads when you're tossing, say, 2 coins, something like that. So the capital E for expectation of random variable x, let's say it's getting heads, okay. It means I want to find the total, okay. So remember, sigma is the total of, in this situation, like say the probability is of getting 0 heads, 1 heads, and 2 heads, and like averaging that out. So that gives us this expectation of getting heads. So there's our mu symbol, and it's just the sum of, your actual event times the probability, and then summing them all up. Another way to write it is like this. It's the same thing, sigma starting from I equals 1 up to I equals n is your event, your sample space, xi, times the probability. But here it's just that, actually I'll unhighlight this and put a different color in so you can see. It's just saying instead of pi, which is the actual number, you're just saying capital B, the probability of random variable x equaling little xi. Okay, now this will make more sense, I think, when we do a question. So let's do this one. Example 1, each time a footballer kicks for goal, he has a 3/4 chance of being successful. In a particular game, he has 12 kicks for goal. How many goals would you expect him to kick? So the probability, or little p, is, the probability, capital P, of getting a goal. I might just put goal in here because you could have, I guess, 0 goals or 1. No, it's actually just goal or not goal, really, isn't it? So you can either get a goal or not a goal. So it's got to be goal. And that's equal to 3/4. So therefore, the expected number of goals would be, we can use our capital E, and it'd be n times p. Okay, so he's going to do it 12 trials multiplied to the probability, which is 3/4. Okay, so back in year 9-10, you probably called this expected frequency, and it's the same thing. And 12 times 3/4 is 9. Okay, so we expect, in theory, that he should get a goal 9 out of the 12 times, in theory, right? It's very different when you actually, say, tally the results and figure it out when you're doing the experiment. Example 2, find the mean of the magazine store data back in example 2. So that's referring to, I think, that was the last exercise we did. And it says explain what it means. Hang on, let me go back and get it for you. where was that one? That was this one, right? We said the magazine store sold 1, 2, 3, or 5 magazines each day. Actually, let's just copy paste our table here. Copy, let's go back down here. Can I paste it? No, it won't let me do it. Okay, well, let me get it. Oh, maybe it doesn't let me paste to another page. No, it doesn't like it. Okay, let's just go back here and read it. So we've got X. Remember, you could get 1, 2, 3, 4, or 5 magazines were bought by people. And these were the numbers, 0.23, 0.38. These were the probabilities, sorry, 0.21, 0.13, 0.05. Now, the question is asking us, actually what I'll do is, and I'm just going to take a snapshot because it'll be easier than flicking back and forth, I think. Let's do that. So here we've got our probability distribution table. Let's insert it. Here we go. Much easier. Now it wants us to find the mean of the magazine store. So the mean is that symbol mu, okay, right, from up here, and is equal to the sum, okay, or sigma, the sum. Sorry, that was a terrible symbol. Let me draw it again for you. Sigma starting with I equals 1, right? And we end at 5, okay? And it is going to be your xi times your pi, okay, whatever that is. And for us, we can see it's going to be 1 times 0.23 for the first one. Plus, remember, sigma means the sum of. Then you got 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05, which is equal to, if we do in the calculator, we should get 2.39. So what it means is, like, overall, the average number of magazines being purchased per customer is roughly 2.39, okay? So therefore, let me summarize for you guys. Therefore, overall, the average number of magazines purchased by a customer is 2.39. Okay. Okay, let's get on to this concept of a fair game. Now, it's not like what you would think fair means intuitively. So in gambling, in this context, we would say the expected gain of a player from a game is like the expected return or payout, like what they, like what profit they make, for example. But you have to subtract how much it costs them to play. So they might have had to put money into play in the first place, okay? Now, when we say a game is fair, sounds weird, but it means the expected gain is 0. So let's say you put in $5 to play, but then you get back $5. That means the game is fair. You haven't made or lost anything. So we would say here, yeah, your expected expectation for your random variable is 0. Okay, so let's do this example. In, say, a game of chance, a player spins a square spinner labeled 1, 2, 3, 4. The player wins the amount of money shown in the table alongside here. Depending on which number comes up, determine ... blah, 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 blah. Okay, so question A. The expected return for one spin of the spinner. So, okay, so that means, okay, let's set this up. So let's let's use Y this time. Let capital Y be the, like, your expected return or payout for each spin. Now, if you've got a spinner and it's just got 1, 2, 3, 4, that means each number has a quarter chance of turning up, right? So therefore, or, you know, landing on it. So therefore, your expected return would have to be, okay, so now we can say E of capital Y is, you know, a quarter of the time you could get a 1, plus a quarter of the time you can get a 2, plus a quarter of the time you could get $5. Sorry, I should have been saying, you know, you could win $1, $2, $5. You could get a 4, but you win $8. Okay, but that's still a quarter chance. Okay, a quarter of the time. Okay. And you can see this is an expectation. This is what we expect in theory. And if you do this in the calculator, you actually get $4. So the expected return in playing this game here is getting $4. Now part B though says, what is the expected gain for the player if it costs $5 to play the game? So that means expected gain, EX, okay, is going to be E of our event Y, okay, minus the $5 it costs to play. So it's $4, take away $5, so it's minus $1, okay, $1 loss, okay. So just be careful with language, expected return versus expected gain, okay. So when you want to know how much you've gained, you've got to take into account how much it costs you to play in the first place. And then C, whether you would recommend playing this game. You would actually recommend no, because the game is actually not fair. It's not, you know, you can't win back what you put in. In that case, the EX should be 0, but our EX is -1. So that actually means, on average, you are going to lose $1 for every time you do a spin. Okay, so since X, capital X, does not equal 0, this game is not fair. Therefore, it is not recommended to play. As the player loses on average $1 each spin, or each go he has or he or she has at the game. Okay, does that make sense? Hopefully that is clear. Please have a go at the questions, which is in exercise 23C, and it is on page 616 in your textbook. And don't forget that you also have questions in the other textbook on Schoology for you as well. I think the Oxford one is the one I've got there for you. So if you want more practice, go ahead and look up questions on the same topic